The South Florida Water Management District problem provides a regression analysis that's already been completed. The only thing that you have to do in this scenario is put it to use. Let's take a look. The South Florida Water Management District must develop a linear regression model that can be used to estimate fresh water needs of various communities. SFWMD has collected data on 50 communities, n equals 50. Okay, that's already been done. Noting each community's population and the total annual freshwater consumption. Using this data, you've calculated the following regression equation. So it's already finished. It's all ready to go. It's right there. Although it's important to know how to interpret it, where X is the population of the community, also known as the independent variable, and Y is the total annual freshwater consumption of that community in acre feet. An acre foot is enough water to cover 1 acre. 1 foot deep, that is a lot of water. All right, what did I mean by put it to use? Look at the first part of this scenario. Using this regression model for estimation, how much fresh water would a community of 1,500 people consume each year? To put it to use, we realize that that statement means or proposes X equals 1,500, so we just want to use this expression, 200.12 plus 24.9, and substitute in that 1,500 to estimate what a community that large would actually consume. I got on my calculator 37,550.12 acre feet. Okay, that's that. It does, however, also ask about a town of 45,000. Same exercise, same expression. 2.12 plus 24.9, we would just substitute in 45,000 here and get considerably more water. 1120700.1 is what's displaying on my calculator. So what is that? That's over 1 million acre feet of fresh water we predict would be consumed by a community of 45,000 people based on this regression analysis. Okay, so continuing to put it to use. What's next? According to this regression model, each new person, now notice each new person who moves into a community increases its annual freshwater consumption by how much? Or another way to think about it is, every time you increase X by 1, because that's the people in the community, the overall result, because that's freshwater consumption, does what? Well, would increase by that amount, right? Yes. This question right here is actually asking for the slope of the line, or B. Or because very often the slope of a line in a regression study is indicating to you the marginal value or the marginal impact, each of whatever it is that you're plugging in as an independent factor. So each new person, according to this regression model, each new person who moves into the community should be increasing the community's overall freshwater consumption by around 24.9 acre feet, just the slope of a line. Then C, according to this regression model, if a town were abandoned such that no one was living there for an entire year, what would the town's freshwater consumption be? And then there's a little add-on question there. Is that possible? Okay, first off, this in a certain sense here is very much like the original question we were working on because it's proposing X equals 0. So you could take X equals 0 and you could write this out here substituting in 0, but, well, I'll do it for the sake of demonstration. We all know how that's going to wind up, right? We have 200.12 times 24.9, but why did we bother? Because times 0. Which is to say we're just going to get 200.12 back. That is water, acre feet. Oh, this business about a community that doesn't have anybody living in it is a disguised way of asking for the intercept of that regression line, or A, right? Because that is the fixed amount that doesn't vary with the independent variable. So what our regression model here, the one that's been given to us, is saying is that if nobody's living in the town for a whole year, the town will still consume 200.12 acre-feet of water. Is that possible? Well, I mean, I suppose that it's possible. If it was possible, maybe it's like leaking pipes or something. But actually, I'm really kind of grasping here. What's much more likely or plausible is a problem of relevant range. You say relevant range? Right. Remember that expression, the 200.12 plus 24.9 times x, that expression was developed from a set of data of 50 communities. I strongly suspect what was going on with the South Florida Water Management District that is on that list of 50 original communities, you know, their population and how much water they used. I bet you there weren't any communities with nobody living in them. Okay, so if you use a regression expression, substituting in an x, you know, an independent variable value that is substantially outside of the range of the original x's in the original data, you're probably going to get a silly answer, right? This hypothesized relationship we expect in reality is going to get weaker and weaker and weaker once you get outside the scope of the original data. So is that possible? I don't know, maybe. Leaky pipes, but you know, probably not. I suspect it's a problem with relevant range.